Okay, welcome to the Dublin Academy. As you know, my name is Mick Dalton, and I'm on YouTube now, so Dublin Academy, you'll find me. If you look for me, you'll find either those names, you'll find it Dublin YouTube. If you want to get in contact me, dublinacademy@gmail.com. Okay, welcome to Leaving Cert Ordinary Maths Series 1, Episode 2, Linear Inequalities. Okay, anything else to put to that? No. Right, so we have, be wary of these. A intersection B, A union B. Cardinal number is the number of elements. Okay, now let's explain this. What is inequalities about? Oh, linear inequalities are just lines that will that improve business actually. But you'll get to them later when they're in the optional question. And the n is a natural number. What is a natural number? A natural number is anything that is whole number. 0, 1, 2. Okay, 0 is so integer. What is an integer? An integer is a whole minus and a plus. Okay, so you might be asked, what are the integers in this set? For example, what x is an element of n. What is it? So when you solve these equations, you'll be able to get a set, which you should be able to put like the x is equal to. Or what's or? Or is a real number. A real number is any number that's on the number line. Okay, so if we have 1 here and we have 0 here, and or is between less than 1, you would say less than 1 and is equal to 0, so you would include 0. So it would go something like this. X is less than, no, not equal to, less than 1 and greater than or equal to 0. Okay, so that's the definitions of that set. Okay, moving along. So that's rational numbers. We'll just leave that line there. So Q is a fraction, anything that can be formed in that form. For example, there you are. Okay. But don't forget the minus goes on the top numeral always. Irrational number is the next one, and that is anything in the form of that, and that is the square root. Okay, or a root sign. It could be the third root of 9, which is well, it'd be the third. That's hardly figured out. Third root of 27, which is what by what by what? It's 3 squared, for example. Okay, so it's anything in the form of a over b. Alright, so we are wary of this. We could be asked them. I don't know. It has been asked before. So I'm going to do some questions now. I'm going to do some. I haven't explained this. So you're reading from left to right. L is greater than or. L is less than or equal to or means also equal but less than. L is less than or. L is greater than or equal to or. L is equal to or. See? So you're reading from left to right here. This is just I'm showing you the way you read as you would normally read. Okay, so let's have a look at the question. This question, we'll pick one of the Leaving Cert questions. Okay, this is question 2005. And it says 3x minus 2 is less than or equal to 4. Now, this is a linear equation, okay? X is an element of z, it says, okay? And you have to just write out just solve for that, solve for z. So z is an integer. So let's have a look at this. We know that. Now, I know some of you have different methods for solving equations, but I have a method that seems to work for everybody. You just bring it across and you do the opposite of its function. So you bring it across and you do the opposite of its function. Okay? So we'll have to solve by the hierarchy of maths. We have to bring the pluses and the minuses over. So we've got 3x is less than or equal to 4 plus 2. 3x is less than or equal to 6. X is less than or equal to 6. Multiplied here, comes across and it becomes division is equal to 2. X is less than or equal to 2. So, and it's an integer. Okay, so how do I express that as an integer? Okay, so we know that the integers are whole numbers, positive and negative. So it's less than or equal to 2, so it includes 2. And it's less than, so it's everything that goes that direction that is whole. So that's 1 0 and all the minuses, okay? Because that's all it says. It says it's less than or equal to 2, so that at the point it's every number that's going that way, that's whole numbers, okay? So you would indicate that they're whole numbers, but they would ask you for, they probably wouldn't ask you to show it, but they have done previously, but this is very difficult to show whole numbers in a line, okay? You have to put circles around them and everything. So moving along here, so that was 2005. I'm going to throw a quick substitution question in here. This is 2006. I know this is off the board, but I meant to do this. AB minus C over 2. A is equal to 3. B is equal to 2 over 3. And C is equal to 1. Okay? Now I put these all in. A is 3. 3 times B, which is 2 over 3. And our fractions minus C, which is 1. All over 2. So I multiply the top by the top, so that's the same as 3, 1 multiplied by 2 over 3, and we know it's the top by the top, the bottom by the bottom. So 2 3s are 6 over 3 minus 1 all over 2. Okay? And well, that becomes 2 minus 1, which is equal to 1. Okay, so that's the answer to that. That's a substitution question. You do get this, I'm just putting them in, but they're just very odd. Okay, they do come up. We'll try another leaving cert question. Let's have a look at one here. So we've got 2 times x minus 1 minus x is greater than or equal to minus 2. Don't forget, these are the questions here you're going to be doing for yourselves. So you will freeze it and you will be able to take them down, I'm sure. So 2x minus 1. So what do I do here? Oh, I can't do anything unless I release these brackets. I'm unwinding, as they saw, unwinding these. So 2 times x is 2x, plus by a minus is a minus. Minus x is greater than or equal to minus 2. So I bring the x's on the left hand side, so I got 2x minus x is greater than or equal to minus 2 plus 2. Okay? And so you got x is greater than minus 2 plus 2 is 0, and you're looking at yourself, how can x be, yeah, you can, x is greater than or equal to minus, or is equal to 0, greater than or equal to 0, and it doesn't say how you have to prove it. What else you have to show? You just show that answer. Okay, so that's the answer to that one. Very good. Now I'm going to do a very large inequality, which is a possibility, because inequalities are very important in business. So we got 3x minus 1 less than or equal to 2x plus 7. Okay, so you got x is less than 3x minus 1, 2x plus 7. So you got two equations here. So you're going to have to separate them. Okay, it's the only way. Well, it's one of the ways to do it. 3x minus 1, and then you've got 3x minus 1 is less than or equal to 2x plus 7. So do you see what I did here? I made that equation, which is here, and I made that equation too, which is here. So what I'm doing is I'm showing my confidence here in deciding what to do, and you will get this after a while. Because it's all through trial, practice, and error. You know, so I'm looking at this equation. I solve this equation, and I bring that over, and it becomes minus 2x is less than minus 1. Now you know how 3 minus 3x plus sign the larger number. Okay, so x. If I multiply across by a minus, or bring across a minus multiplied by, I must change the direction of this sign. Okay, and so there you go. And so now I'll repeat that again. If I divide across by a minus, I must change the direction of the sign, because in fact you're changing the fundamentals of this x. So you're inverting it, but you're making the equation totally different here. So I'm not going to get into it, but if you have a multiplication and you bring it across and you divide and it's a minus, you change the direction of the sign. So minus into minus is a plus, x is greater than a half. Now you've got the next one. So you got 3x minus 1, you bring the x's together. 3x minus 2x is less than or equal to 7 plus 1, x is less than or equal to 8. Okay, now so we bring in these two together. We know that x is greater, we put x in the middle, x is greater, I'll put this in the red pen, x is greater than a half, but it's less than or equal to 8. Okay, you see that there? Okay, so I've brought that in. It's still, x is still greater than a half, but I turned it around because I want to fit this in here. Okay, right, I'm continuing on. So that was a rather tough inequality. I shouldn't expect them to get any tougher. I know. Put them down. Okay. Right, so I'm going to leave it at that then. I'm just looking through here the papers and there doesn't seem to be anything there that I have missed. But remember about the inequalities, okay? Now, I'll just a backdrop. These inequalities give you lines, okay? That one inequality can give you another line and you another line and you end up with an area there. That's the area you can function in. As a business, because all these are extremes, you cannot go there because they don't give you profits or they don't hit, you can't hit your electricity targets, whatever, you know. You have them all in here and you're dealing with this area and you usually take the extreme points and you put it into a profit equation. You know, and you put the extreme points and you see which ones gives you, and then you know what you should, how much of what you should be producing. Okay, that's for me now. So the questions here, have them by the next time. Thank you. Bye.